So the next question is, this question is basically from general equilibrium or exchange economy topic. So question number 46, it is also asked in GATE 2024. So basically we have two, you can say consumer, Anu and Binu. Okay. So utility function is given for both the individual. Anu has a perfect substitute type utility function, and Binu has a perfect complement type. Okay, and initial endowments are given that 0 apricot and 12 banana, and Binu has 12 apricot and 0 banana. Okay, so we can figure out the income for both the person, and then if we will calculate the optimal outcome of Binu, so it is a perfect complement thing. So if you will be able to, like, if you will want to, you can say B of Binu and A for Binu. That is optimal amount of banana and optimal amount of apricot for both for Binu. Okay, so this will be the formula used is this only. Okay, so this is simple. Like if you will normally optimize it, or you can use the certain condition for perfect complement thing, you will be easily get this value. Okay. Now, in order to solve the competitive equilibrium, we will assume that price of banana is equal to 1, and then we will try to check the three cases, and the three cases will be like MRS, like if we assumed PB is equal to 1, then price ratio can be 1 by 2, less than 1 by 2, and greater than 1 by 2. Why three cases? Because Anu has a perfect substitute thing, and in perfect substitute, you know that optimality condition is basically derived by considering all the three cases. Like MRS should be equal to Px upon Py, or MRS is less than Px upon Py, or MRS is greater than Px upon Py. Okay, so we have used that condition, and you know that in order to calculate the competitive equilibrium in exchange economy, we have to take the, like, we have to consider the utility function of both the pair. Okay, so we easily know that in perfect complementing it is not that hard to figure out, because there we have only one case, but in case of perfect substitute we have three cases here. Okay, as per the given, you can say utility function. Okay, so we will consider first case, that is case 1, that is PA equal to 1 by 2, or it is MRS equal to price ratio, and then we will use the condition of total demand is equal to total supply. So total demand is basically the demand of Anu for apricot and demand of apricot for Binu. So first we are considering apricot thing, like we will analyze the demand for apricot, and if condition will satisfy, then we will be easily able to figure out the demand for banana. Okay, so now we will figure out the demand for apricot in case of Anu. So we all know that if the utility function is perfect substitute, then we have this condition that it will be the optimality condition will be 0 to M of Anu to the price of apricot. Okay, and this one we have like previously figured out that what will be the A of Binu, like optimal amount of apricot for Binu, that is using this formula. So this will be calculated as 12, and if you will put the values, it will be 0 to 24. So in order to get the condition satisfied, that is total demand should equal to total supply. Like you all know that Walrus is the economist who is behind this exchange economy concept. So there is a statement by Walrus that the net excess demand of should not be like zero. Like you can say the net excess demand should be zero. Like excess demand case is not applicable. Okay, so excess demand should always be zero. And what does it imply? That total demand should be equal to total supply. So if that condition has to be satisfied in this case, then you can easily figure out that this 0 to 24 value has to be 0, because 12 is fixed. We cannot change this value. But here we all know that optimality can arise between 0 to 24. So 0 can be taken. So optimal, you can say allocation, yeah, optimal consumption for Anu and Binu for case of apricot will be 0, 12. So this is So this is the analysis of first case. Now we have second case. Here MRS is less than price ratio. So if MRS is less than price ratio, then you can say that price of A is less than price of B, and thus Anu will consume all of apricot. Okay. So if Anu is consuming all of apricot, then the formula used to calculate the optimal amount of apricot in case of Anu will be income of Anu upon price of apricot. So this will be 24 plus this is we have calculated already that in case of perfect complement what will be the AB, that is 12. So if you will figure out that this is basically exceeding the total supply. So this is the excess demand case. So this condition or this case is not valid. Now we will analyze for third case. That is MRS is greater than price ratio. Okay. So if MRS is greater than price ratio, then we have this that A of Anu will be 0. Why? Because MRS is greater than price ratio and this will be 12. So Anu will be consuming 0 of apricot and uh, and okay and banana will be 0. Okay. Sorry, A for Binu. This is A for Binu. This is not A banana. So A for Binu will be 12 only. So this case is also valid. So it is clear that PA greater than 1 by 2 Anu will be consuming all of banana. Why? Because C is consuming 0 amount of apricot. So if you will look for like if it is the price is different, then Anu will be consuming, and if Anu will be consuming all of banana, then formula will be simply this. Okay, M of Anu upon PB. So optimal consumption for Anu will be 0 unit of apricot and 12 unit of banana. So if you will go through the options, option D will be correct because in question it is asking which one of the following will be Anuj optimal consumption bundle. Okay, so option D will be correct.
So let's solve this question. This is from IIT GATE 2024, question number 47. It says a dual economy consists of a manufacturing sector and an agricultural sector. So dual economy, so you have two sectors. First is the manufacturing sector, which is given as M, and second one is the agricultural sector. Now in the diagram, if you see, OMOA is the total labor available in the economy. So if you see in the diagram, this is OM and this is OA. So this entire horizontal axis represents the total amount of labor which is available in the economy and who are working either in the manufacturing sector or in the agricultural sector. Now, OM, OM LSM. So OM LSM. So this is the amount of labor supply in the manufacturing sector before any migration was allowed. So before migration, what happens is that OM LSM is the amount of labor who are working in the manufacturing sector. So what is the amount of labor who are employed in the agricultural sector? That will be OA LSM. So the rest of the portions basically. So this entire labor will be employed in the agricultural sector initially when the migration was not taking place, right? So this was the scenario, pre-migration scenario. Now what happens? The vertical axis in the left and the right side measures the wage in the manufacturing sector and in the agricultural sector. So this is the wage in the manufacturing sector and this is the wage in the agricultural sector. Okay. Now the question says LDM, LDA is the demand for labor in the manufacturing and agricultural sector. So if you see this is the demand curve in the manufacturing sector and this is for the agricultural sector. And OMOA are the origins. So this and these are the origins of manufacturing and agricultural sector respectively. Now it says if the wage is flexible, labor is allowed to migrate between these two sectors, then what will be true? So if you go by the options, total amount of labor that will migrate from agriculture to manufacturing sector is this. Total amount of labor that will migrate from manufacturing to agricultural sector will be this. The wage in the manufacturing sector will be W3 or the wage in the agricultural sector will be W1. So first, let us see, let me remove these things and understand what will be the initial wage in both the sectors. So initially, the question said that this is the amount of labor employed in the manufacturing sector. So let's see from the demand curve. If you go by the demand curve, so this is the demand curve for the manufacturing sector. So from this point, you know what is the wage rate prevailing before the migration? W1 was the initial wage rate. W1 is the initial wage rate that was prevailing in the manufacturing sector, right? So how do you get that? So corresponding to the amount of labor employed, if you put this labor into the demand curve, you get the corresponding wage. So this was the initial wage rate in the manufacturing sector. And similarly, how do you find the initial wage rate for the agricultural sector? Similarly, this is the demand curve. So from demand curve, if you join this, this is the initial wage rate for the agricultural sector. So clearly what you see, let me write, this is the initial wage rate for the agricultural sector. So clearly what you see is that W1 is greater than W3, right? So the initial wage in the manufacturing sector is clearly strictly greater than the initial wage in the agricultural sector. And what does this tells you? This tells you that the migration will take place from the agricultural sector to the manufacturing sector, right? The migration will take place from the agricultural sector to the manufacturing sector. Why this is so? Because the wage rate is higher. So people will go to obviously to the higher wage rate sector, right? So from agriculture, people will go to shift to the manufacturing sector. They will migrate. So this, basically eliminates your option B because it tells the total amount of labor will migrate from manufacturing to agriculture. So this will not take place. Since the initial wage rate is high in the manufacturing sector, so people will migrate from agriculture to the manufacturing. Okay. Now let's see option C. It says the wage rate in the manufacturing sector will be W3. So this is also not true because we see that wage rate in the agricultural sector is W3 and not in the manufacturing sector. This is false. The wage rate in the agricultural sector will be W1. Obviously, this is also false. We have just said that W1 is the initial wage rate for the manufacturing sector. Now, you have to find out the total amount of labor that will be migrated. So you, by elimination, A is the right answer, but just to see the logic. So for that, to see how many laborers will shift, you have to know the stopping criteria of migration. So what is the stopping criteria? Stopping criteria of migration. What is that? Migration will stop when the labor demand curve in the agricultural sector and the labor demand curve in the manufacturing sector will intersect each other, and the wage rate in both sectors will be equal, right? Wage rate in both sectors will be equal. So when will the migration process stop? When the labor demand and the labor demand curve for both the sectors match, that will be intersect, and a common wage rate will be determined, and that will prevail in both the sectors. So if you see in this diagram, here this is the labor demand for manufacturing, this is the labor demand for agriculture. So they meet at this particular point, right? So they intersect at this particular point, say point E. And corresponding to this point, what will happen? This is the equilibrium wage rate, W2 star. W2 star will be the equilibrium wage rate that will prevail in both the sectors, both in manufacturing sector and in agricultural sector. And this will be the optimal amount of labor that will be employed. So from the origin, if you see, OMLA is the optimum labor that is employed in the manufacturing sector now. And LAOA or OALA, whatever you call it, this is the optimal labor that is employed in the agricultural sector, right? So let me write that down. OMLA is the new labor employed in the manufacturing sector, and OALA is the new amount of labor which is uh, employed in the agricultural sector. So what do you see? What is the migration? What is the total amount of migration? So initially, OMLSM was the amount of labor who were employed in the manufacturing sector, and now this amount goes to this OMLA basically. So what is the amount of migration? Migration is this amount, LSM LA or LA LSM, whatever you call it. And that is what this option tells you, the total amount of labor that will be migrated from the agricultural sector to the manufacturing sector is LSM, right? So let me just give you a quick recap of whatever we have done. So initially, what was happening is that initially this is the amount of labor that were employed in the manufacturing sector, and the rest of the portions were in the agricultural sector. Now, when these two demand curves intersect, the common price level is fixed at W2. Corresponding to this, we see that in the manufacturing sector, we now have increased labor supply, right? Since the wage rate was initially high, since this was the initial wage rate prevailing in the manufacturing sector, in order to reach this wage rate, W2 equilibrium wage rate, it has to fall. Wage rate can only fall if you increase the amount of labor that are employed in the economy, right? In the manufacturing sector particularly. So if you increase the labor from this to this, then what will happen? This wage rate will come down and ultimately reach to this equilibrium wage rate, which is W2. And in the agricultural sector, what happens is that the wage rate initially was W3, and now people migrate. People basically migrate from agricultural sector to the manufacturing sector, and hence, due to the shortage of labor, due to lack of labor, scarcity of labor, the wage rate will rise, and ultimately both will stop at W2. So here the right answer will be A, that the total amount of labor that will migrate from agricultural sector to manufacturing sector will be LA. I hope you understand what I have tried to tell you. And so this was the question number 47, IIT GATE 2024. Hi everyone. So this is question number 48 from IIT GATE 2024. So it says if x and y are two random variables, so you have two random variables x and y with the joint probability density function as this. So this is the density function when x and y both are between 0 and 1 and 0 otherwise. So this is the density function that is given to you. Now see, what do you have to find out? You have to find out this conditional expectation, right? Expectation x given y equals to half. This is the conditional expectation of x. So in order to know the conditional expectation of x, you have to know something called conditional probability density function. Right? You have to know the conditional probability density function for x. Now, how do you find that out? This will be simply this. So the conditional expectation x given y. This is the density function, and what will this be? This will be simply this. So in the numerator, you have this joint density function, and in the denominator, you have the marginal distribution of y, right? So this is the conditional distribution, and you have to know this conditional probability density function in order to find the conditional expectation, right? So now let us do that. For that, firstly, we will find this. This is the marginal density function. This is the marginal density function of y, of the random variable y. So let us find that out. If y, what will this be? In order to find the marginal of y, you have to use the x range, the range for x. So x is from 0 to 1, and then you have this joint probability density. This, right? So you have to use the range of x, and then you are using the joint probability dx. So let us find that out. So take this 2/3 out, and here what you have x here. So x squared by 2, if you integrate 2y, so it will be 2xy. And you have to apply this range. So if you put 1 here, it will be half. Put 1 here, it will be 2y. Put 0 here, it will be 0. Put 0 here, it will be 0. So 2/3 half plus 2y. Or if you simplify, it will be 1/3 plus 4y by 3. So 1 plus 4y by 3. So this will be your marginal density function of y. Okay. Now what do you have to do? Now, if you go back to the question once, see this expression. Here what you have, x given y is half, right? The value of y is given to you. So what will be this? So instead of y, you are writing half. So it will be 1 plus 4 into this upon 3. So it will be 1 plus, this is 2. So 1 plus 2 upon 3. 3 upon 3 is 1. And since you have the joint distribution with you, you can find out this expression also, right? What will be that? This is 2/3 x plus 2y. 2/3 x plus 2 into y. So 2/3 x plus 1, right? This will be 1. This is the expression. So if you have these two things, you can easily find out what will be this. That will be simply f of x half upon f y of half. So 2/3 x plus 1 upon this is 1. So this will be the expression. This will be the conditional probability density function that I was talking about, right? Conditional probability function of x given y. So this expression we have calculated, right? So this entire expression. Now what will be the expectation? If we have this conditional thing, then we can easily find out what will be the expected value of x given y equals to half. This will be the range of x into simply this conditional distribution to dx. So now you have to calculate this expression, and that will give you your expected value. So x is from 0 to 1, x into this expression. So 2/3 x plus 1 dx. Simply take this 2/3 out. X is from 0 to 1, and here you have x squared plus x dx. So this is 2/3. And if you integrate this, this will be x cubed by 3 plus x squared by 2. And then you have to apply this. Put 1, so 1/3 plus half minus this will be 0. We put 0 here. 2/3 into so this will be 3. So you have 5 upon 9. And this will be your expected value of x given Y. Let's see the option. So it is option number E. Okay. Hi everyone. So let us do question number 49. This is IIT GATE 2024, question number 49. So it says if a discrete random variable x follows uniform distribution and assumes only the values 8, 9, 11, 15, 18, and 20, what will be this probability, right? So it is given to us that x follows uniform distribution and it assumes the values 8, 9, 11, 15, 18, and 20. So only the 6 values. So what will be the PMF? What will be the PMF of x? That is probability mass function. Since it is a discrete random variable, we will call it probability mass function, right? So x takes this values 8, 9, 11. Let me not write it. So we know that for all these values, the probability has to be the same since it is an uniform distribution. So the mass at each of this point, probability mass at each of this point has to be the same. So it will be 1 by 6 because it can assume 6 values. So the mass will be 1 by 6 when x assumes this values 8, 9, 11, 15, 18, 20, and it will be 0 otherwise, right? So since you have an uniform distribution, your probability mass function will look like this. For all these values, you have the mass, probability mass to be 1 by 6, and otherwise, for other values, the value is 0, right? Okay. Now let us simplify this expression. This expression, this is probability mod x minus 14 is less than 5. So you can write it in this way, minus 5 less than x minus 14 less than 5 from the property of mod, right? Now you can add 14. You can add 14 to all the sides. What will this be? This is 7 and this is 19, right? Okay, so this is 9. Sorry. So this is 9 and this is 19, right? This is what you have. Now look at these values. What are the values x can assume? Assume these values. So find out what are the values which lie in this range, 9 and 19. So 9 is here. Then you have 18. So what are the values? What are the permissible values that this random variable x can take? Here, it can take the value 11, it can take the value 15, and it can take the value 18. In between 9 and 19, you have only these 3 values, right? So here, in calculating this probability, you have to take into account only these 3 values. So this probability will be equals to probability x equals to 11 plus probability x equals to 15 plus probability x equals to 18. Now we have just wrote from the probability mass function that for all these values, the probability mass is 1 by 6. So for this, it will be 1 by 6. For this, it will be 1 by 6. And for this also, it will be 1 by 6. So it is 3 by 6, which is half. And that will be your answer. Answer is A. And yeah, that's it for this question. Okay. Hi everyone. So this is question number 50, IIT GATE 2024. So let's do this. It says assume the following probabilities for two events A and B. Probability A and probability B is given to you. You also know probability A union B. Then what we can conclude. And you have 4 options. A and B are mutually independent. A and B are are equally likely. A and B are not mutually independent. A and B are mutually exclusive, right? So, for mutual independence, for mutual independence, what is the condition you need to know? Probability A intersection B is probability A into probability B. So this is the condition you need to know. If this satisfied, then you will say that yes, the events A and B are mutually independent, otherwise they are not. So let us find this. What will this be? Probability A union B. What will be this? This is probability A plus probability B minus probability A intersection B, right? So this thing we know. A union B is 0.85, A is 0.50, B is 0.70 minus probability A intersection B. So this is 0.85, this is this A intersection B. So probability A intersection B is 1.20 minus 0.85 is 0.35, right? This is all you have here. Probability A intersection B is 0.35. So this part we know. And these two things are given to us. These two things are given to us. What is probability A into probability B? Probability A is 0.50 into probability B is this. So this is again 0.35, right? So what we see here is that yes, this condition is satisfied. Probability A intersection B is exactly equals to probability A into probability B, which is equals to 0.35. So A and B are indeed mutually independent. So this is not right. Now A and B, is it equally likely? Equally likely means what? A and B has the equal probabilities. But we know here that probability A is 0.50 and probability B is 0.70. So they are not equal. So this option is also not correct. And for mutual exclusiveness, you have to check this. If this criteria is satisfied, then they are mutually exclusive, otherwise they are not. Since we know that probability intersection B is 0.35, so it is not equals to 0. So this option is also not correct. So your correct option is A, which is A and B. A and B are mutually independent, right? This is your answer, option A.